Welcome to section 3, training a supervised learning model. This is lecture 13, interpreting the XGBoost model. So I've trained the same XGBoost model that I implemented in lecture 12 with the two hyperparameters. And in this notebook, I wanted to show some of the attributes that we do have at our disposal. So one of them being the model.classes attribute, which again, we have access to the different classes. We could have a multi-class classification problem where instead of just fraud, yes or no, it could be, something with 4 classes or 5 classes potentially. This might be a useful attribute that allows us to see, well, this model, this is exactly how many classes the model's been trained to predict. Then with XGBoost, one of the nice features is the feature importance attribute that's built in, and that allows you to inspect in the same way that the model coefficients, in a sense, the same insights that gives you in terms of the model contributions. The feature importances for the XGBoost features do something very similar, where we can actually go in and see the most the most positive or the highest magnitude positive instance, although they're all positive in this case. That would be the feature that contributes the most significantly to the detection of the positive class. And in this case, it would be feature 14. So if you remember this, they're completely different algorithmic approaches. So you're not going to get, you wouldn't expect to get much overlap in terms of, which features contributed most to the detection of fraud. If you trained a logistic regression versus XGBoost, completely different approaches. There might be some overlap, but I wouldn't bank on there being strong overlap. But in this case, feature 14 appears to be the strongest from an XGBoost perspective. And I remember that was second for the logistic regression, and first for logistic regression was feature 4, which is also quite strong, one of the strongest, but not the strongest. The strongest for the XGBoost is feature 14.